Looks like we're about to start this run between University of Illinois Chicago and San Diego State University. We just got our live stream up and running again. We're gonna have to get the new URL advertised to everybody. So bear with us while we get the new URL posted to our website. So UI. Oh, look at the UI robot turn. UIC robot. It has a rocker bogie suspension, 6 wheels, and looks like the front and rear wheels can rotate, just like the front wheels on your car can rotate in order to turn. And the San Diego State robot at the top of the screen is does not appear to be having any trouble getting across the obstacle zone. And the UI Chicago robot appears to be now pointing roughly in the right direction. It looks like the rear left wheel was just dragging just then. Yep, it's dragging. That could be an issue. It looks like both rear wheels are dragging. You can see by the trails that it's leaving behind. Now, it seems like that robot's other wheels were able to overcome that additional obstacle. But boy, things would sure be a lot easier if all 6 of these wheels were being powered. Here's a good close-up view of the San Diego State University robot, just now starting to plunge its bucket ladder system, where several buckets are attached to a flexible conveyor, possibly a rubber conveyor. Looks like if it grips a little too much, it ends up stopping the system a little bit. But if they're grabbing just the right amount, it looks like they're able to make good productive progress. Whoa, look at that UIC robot lifting its front wheels off the ground. So San Diego State University at the top of the screen, University of Illinois Chicago robot at the bottom of the screen. The UI Chicago robot has a very interesting rocker bogie suspension system with 6 wheels. The front and rear wheels of the 6-wheel rocker bogie system can obviously rotate, as you can see in this view. It looks like they're probably trying to turn to the left and get past the berm. Meanwhile, San Diego State University at the top of the screen, you can see from this angle, you can see as those buckets come around the top of that conveyor belt, they are throwing their load into a hopper that is a wire mesh. And so what I suspect is happening is the fine material that is not scoring material is going to be going right through that mesh. And it's just the gravel, the rocks, that are going to be remaining in their onboard hopper when they finish digging. San Diego State University is really starting to get a pile, and you can see how far their digging system just plunged down into beneath the soil. You can see how it's going up and down. So they may be pulling their system up out of the ground, and nearly 5 minutes into this 15-minute run, they may be about to head back to the starting point. Now you'll notice the San Diego State students installed some cardboard with their logo on the far end of the arena. I don't know if that's just for fun and just for marketing purposes. It is possible that a camera system on board the robot could use the logo for recognizing where it is in the arena, or at least recognizing where the lander is and how to align itself with the lander. Or it's possible they just did it just for fun. There's a crater that the San Diego robot just went into a little bit, but I think this robot will be able to get past that crater. Oh, that one of those wheels turned a little bit in a direction that made me a little bit nervous, but they got past it, thankfully. San Diego State University at the top of the screen, heading back to the lander for their first cycle, and if their offload system works reasonably well and reasonably quickly, they'll have plenty of time to go back and dig some more. And it'll be interesting to find out if they try and go into the same hole that they were in earlier in order to go even deeper into that hole, or whether they start at a completely different hole. On the bottom of the screen, you're looking at University of Illinois Chicago's robot that had some mobility issues when it first started. It was able to get itself out of the starting gate, out of the starting zone. The rear wheels, you can see from the tracks, did drag, and they were not being powered for some of that motion. Actually, most of that forward motion happened with the rear wheels just completely dragging along. And since then, they have been possibly doing some troubleshooting, possibly doing some uh, playing around with different scenarios. At one point, we saw the front wheels go way up off the ground. You can still see in this overhead view um, uh, two of their wheels, which implies that the ones on the other side are moving too. So four of their six wheels um, powering and moving in order to try and correct the situation that this robot is sitting in right now. Okay, at the top of the screen, San Diego State robot has apparently aligned itself with the lander, and it almost looks like you can see some rocks in its bin. I know there's quite a bit of this gray um, crushed volcanic rock in its bin, but it's a bin that has lots of holes or a wire mesh, and so it's really not intended to hold on to a lot of that um, fine particle. It's really intended to hold on to just the rocks, the gravel that are there. And it doesn't look like the bucket was able to get far enough beyond vertical to really let all of their material out. We don't have a camera view from the perspective of the judge's eyeballs right now is the best angle, but we don't have a camera right there available to show you. But as this dump bed falls back down, you can see there's still quite a bit of material sitting inside that dump bed, which is a little sad to see after all that work. There are 6 minutes remaining in this run. Is San Diego State going to go back for more? It looks like they are. And it looks like University of Illinois Chicago is still trying to get their robot past where it has been sitting for a while. They appear to be doing a few more aggressive movements than we've seen before, which seem to be getting some of their tires dug in a little bit deeper. Looks like San Diego State is heading to a different spot than they had dug in before, and we're getting close to the 5-minute mark remaining on this run. in the background. From this angle, you can see how high the University of Illinois Chicago robot can lift their digging mechanism. Um, I'm not sure. It's possible yeah, I'm fairly certain that is how they will dump once they've dug. That the the underside, um, the curve uh, of that onboard mechanism is probably their onboard hopper, and this is probably where they raised their entire mechanism in order to dump out um, what they have on board. Well, University of Illinois Chicago is really getting aggressive with trying to get their robot unstuck with about 4 minutes remaining in this run for these two teams. Their first run of two official competition runs. This angle gives us a good look at um, the onboard hopper for the San Diego State University robot, and it also gives us a good view of their bucket ladder system, bringing the dirt up and over on that conveyor belt and dumping into their onboard hopper, which is a steel mesh or a wire mesh basket. Now, earlier when UI Chicago raised their mechanism, their digging and dumping mechanism super high, it's possible that they were, just testing out that mechanism in the arena. Oh, look at how full some of those buckets are on the San Diego State University robot. It's also possible that the UI Chicago robot, that the team decided to raise their system that high in order to change the center of gravity and change the weight of where the robot's weight was on the ground in order to possibly help maybe get them unstuck from that position. 2 minutes and 40 seconds remaining. So for those who are listening in the pits, you can get to our new live stream. It has a new URL. And the easiest way to get to that is to go to nasa.gov/lunabotics and click on the watch live link. That's the same place you got to our earlier stream, but we have updated it with a new link. And so um, our new live stream, which we have finally gotten up and running, is now being offered up from our nasa.gov/lunabotics website. So there are only 35 people watching that stream right now, and we had nearly 200 viewers earlier. So um, if everyone who's in the pits is able to go on social media and tell all of their friends and family um, to go find the link to our stream on nasa.gov/lunabotics, that would really help us um, get everybody switched over from the old earlier stream URL to the newer um, stream URL. We would really appreciate your help. We have 1 minute left in this run. It looks like the UIC robot. I think they were just doing some digging, just for fun. Might as well do some digging. Since you're in the arena, you're only going to get 2 opportunities to be in the arena this year, so you might as well test out your systems to the and not waste any time while you're in the arena. 30 seconds left on this run. All right. From this view, we can really see that UI Chicago, we can see their digging mechanism. That's I'm really glad that they decided to go ahead and try some digging, even though I wouldn't score them any points. And with that, our 15-minute timer has expired. So the University of Illinois Chicago at the bottom of the screen and San Diego State University at the top of the screen should be really proud of what they've accomplished. Hopefully, they can go back to the pits and fix whatever needs to be fixing, and have really great runs, uh, scoring runs tomorrow. So don't go anywhere because we have upcoming next University of Portland and the University of New Hampshire. And then after that, we have Montana Tech and University of Arkansas. And everyone who is in the RoboPits that can hear my voice, if you could go to our new live stream, which is at nasa.gov/Lunabotics, and go in the chat and tell the folks there what they missed. What happened was our initial live stream went down right towards the end of the Sonoma State and Marquette University um, uh, competition. And so those people who were watching the stream, they missed the fact that Marquette was unable to. They missed the fact that Marquette got stuck on the berm on the way back to the lander. So let them know that Marquette got stuck and they were not able to offload. And then please let them know what happened in the 2 runs after that, if you don't mind filling everybody in the chat with what they missed. And that will hopefully keep all of the folks from asking a million questions if we could just kind of get ahead of that. So again, coming up next is University of Portland and University of New Hampshire, and then Montana Tech University and University of Arkansas. Do not go anywhere, and tell all of your friends and family about nasa.gov/Lunabotics, which is the place that they can most easily find the link to our new and improved and working fine live stream for the rest of the afternoon. Don't go anywhere. We will be right back at NASA Lunabotics 2022 competition here in Kennedy Space Center's Visitor Center here in Central Florida. Said Portland and New Hampshire should be coming up next, and then after that, Montana Tech and Arkansas. But I do want to note that University of Arkansas's run is just going to be a demo run. It won't be for points. And then looking ahead, looks like we're going to have, as soon as they're past all their inspections, we will have North Dakota State University and South Dakota School of Mines. And then after that, we will have Lone Star College, Sci-Fair, and the University of Maine should round out our day.
My name is Claudia Bernier.
My name is Matthew.
Mi nombre es Miguel Marcelino.
My name is Ali Hyder.
Kai Kos.
Christy Yoon.
Bashir Makea.
Carlos Catalano.
Tess Von Rudin.
My name is Sarah Adabumi, and I am a NASA intern.
Jesse Moody, and I'm a NASA intern.
Pathways Engineering intern.
I'm a NASA intern.
I'm a NASA intern at NASA Kennedy Space Center.
At Ames Research Center.
NASA Langley in Virginia.
At Goddard Space Flight Center.
OZ Department at Johnson Space Center.
At the Human Factors Engineering team at the Marshall Space Flight Center.
My name is Tina Shermer, and I'm a Pathways intern at NASA's Glenn Research Center.
I'm Jamarius Reed, and I'm a NASA intern for the Office of STEM Engagement, working in the Aeronautics Directorate at NASA Ames Research Center.
My name is Courtney Goldman, and I'm a NASA OSIM intern at a Kennedy Space Center.
I'm currently working with the Psychophysiology Research Lab.
I study how nitrogen functions in extreme environments.
In bioinformatics for spacecraft production.
The synthesis analysis of multidimensional ozone measurements.
I supported the X-59 Quest low boom flight demonstrator project.
I decided to apply to a NASA internship because it sounded like the chance of a lifetime to work alongside the innovators and pioneers at NASA.
We get invited to lectures from astronauts, inspiring researchers, and get to hear about smaller missions that I wouldn't have known about.
And being able to work with all of the amazing people here has truly been out of this world.
I like feeling like I'm contributing to something bigger than just me.
All the different projects that they're funding or different projects that they're investing their resources in is really inspiring.
And NASA did an excellent job providing me with meaningful work and making sure that everyone on the team felt included and involved.
From daily or weekly check-ins, my mentors guided and advised me through my projects and any help that I needed.
I feel that NASA is a source of innovation and inspiration for people of all ages and backgrounds.
But you're also around people that are humble, driven, again, passionate, really coming to work, wanting to work, because they care so much about this goal, this mission.
And all NASA wants to see is that you share that passion as well.
Always remain persistent. Everything doesn't happen the moment you want it to happen. Everything happens when it's supposed to happen. So if you apply 2 or 3 times and you don't get accepted, keep trying.
We are the Artemis generation, and I am proud and so grateful to take part in getting the next man and the first woman to the moon.
NASA welcomes everyone. It welcomes you.
If you're interested in NASA at all, apply online today. I did not think that I could get an internship with NASA, but I applied anyway, and so I think you should too.
On the screen, you can see two teams that have placed their robots into our Artemis arena. We have the University of Portland on the right and the University of New Hampshire on the left. And I do not believe the teams have started their official setup time. I believe they're waiting for the arena judges and the control room judges to tell them that it's time to set up the robots, meaning they can turn them on, activate them, verify data, verify commands, that sort of thing. This Portland robot on the right with the brightly colored orange wheels. When you see bright colors like that, it's usually an indication of 3D printing product. And so I'm pretty sure these 6 wheels on this Portland robot are 3D printed using some sort of a plastic. And based on the way the different wheels are pointing in the different directions, I'm assuming that the robot starts out in a folded up position, and once activated, I'm assuming that the wheels are going to spin around and probably be wider than the required starting width for a robot. You'll notice in this competition that some robots are designed to start up in a folded up position, and then they will deploy into the actual operational position once the competition is started. And that's by design. That's because the requirements, one of the many requirements of the competition are that the robots all start out under a certain size. That size is 1.1 meter by 0.6 meters by 0.6 meters. All robots may deploy or expand after the competition has started, as long as they do not exceed 1.5 meters in height above the surface. So once this Portland robot expands its wheels into the operational position, it'll be obvious that they're using a rocker bogie suspension system similar to the robots that NASA has operating on Mars, Curiosity, Perseverance. And this is a fairly common suspension system used on exploration robots. But the reason we don't see more teams in this competition use that type of system is it does add complexity, more moving parts, and possibility for parts to not work the way they're intended. I'm not trying to imply that this is a bad decision on this team. If done correctly, if done well, if they're using good design principles, good manufacturing principles, and have done their homework and done the proper amount of testing and experimentation, it could really work well for them. And that risk of having the added complexity could really pay off. I just noticed on my computer screen that we are halfway through the setup time for these two teams, and the University of New Hampshire team, which is on the B side, on the left side of the screen, they have already left the arena. So I'm assuming that their robot is set up, powered on, activated, ready to go. No issues found, no concerns. And now we see the Portland students exiting the arena. And so it's possible that they may also be ready to go. So stand by for this first run of two that we will see this week for these two teams, University of Portland on the right and University of New Hampshire on the left. And for anyone who is just now tuning in to our new live stream, we're about to see University of Portland on the right and University of New Hampshire on the left. After that, we're going to see Montana Tech University and the University of Arkansas. Now, Arkansas's run will be a demo-only run and will not be scored. After that, we'll see North Dakota State University and South Dakota School of Mines and Technology. And then after that, we will see Lone Star College, Sci-Fair, and University of Maine. And I think that would be the end, or is my I'm not sure. We lost our other screen, so I'm not sure if there are any teams queued up on our schedule after that because we lost our screen. All right, we have motion from the University of New Hampshire robot. Came out of the gate fast. Something is set on high gear on this robot apparently. Let's see if the students in the control room can maintain good control over this robot over the next 15 minutes. So University of New Hampshire on the left, University of Portland on the right. Sometimes, and we've seen this several times, sometimes it takes a minute or two for things to get working for whatever reason. The New Hampshire robot has made a couple linear moves backwards very fast and then forwards pretty fast. Here comes Portland doing a pure rotation around its center, although this wheel in the middle seems to be not really helping at this moment. The other wheel on the other side in the middle isn't helping either. You can see both of their center wheels from this angle, and neither one appears to be doing useful work right this second. Now their other four wheels are going to want to be pointing in the same direction in order to do useful work. That does not appear to be the case just yet. So hopefully this Portland team will be able to fix these issues and get this robot up and running and mobile. This robot did a pretty great job of rotating, even though those center wheels were not pointing in a useful direction. We can see the one wheel of the New Hampshire robot spinning just then. I'm not sure why just one of its wheels was working. Still see some motion on the Portland robot's center wheel. At least one of them appears to be rotating around to get into the correct pointing angle. Both of these robots need to get pointed in the right direction and then drive across our arena and get over to the digging area. We've spent nearly 4 minutes out of our 15-minute time window so far. Motion from the Portland robot. But we can see that the front and rear wheels on the left side of the robot, which is towards the bottom of the screen, appear to be in a circular position. But at least the front right wheel is not in that same circular position. It seems to be in a driving straight forward or straight reverse position. So it almost seems like the left side of the robot and the right side of the robot is not in sync for some reason. And it's been a while since we've seen motion out of the University of New Hampshire robot at the top of the screen. We are now 7 minutes into this 15-minute run for these two teams, University of Portland on the bottom of the screen and University of New Hampshire at the top of the screen. And both robots have moved, which is really good to see, because we had a lot of robots Monday and Tuesday that never moved from their starting position. And you can see Portland's wheels are now, almost all of them are straight. So the students who are operating this Portland robot in their control center appear to be aware of the issues and working the issues one issue at a time. And the New Hampshire robot hasn't moved in a while. It did drive straight back, and then it drove straight forward. And then we saw a little bit of one of the rear wheels spin for a second. I'm not sure I've seen anything happen since then. Okay, Portland is moving a little bit, but backwards, it looks like. This robot can't go backwards because it looks like it is touching the lander. And now it's driving forward, and it is now free of the lander. There are some wire bundles dangling down. Am I seeing that correctly? Are there wire bundles that are like being driven over by the wheels right now on the left side of this robot? That is not a good situation if this robot is running over its own wiring and ripping wires out of place. That would be a bad situation. I don't know for sure that those are wire bundles. Still seeing a little motion from the Portland robot. I'm not sure if the students are able to see what we're seeing. They do get an overhead sort of an angle if they decide to use it. Only the judge in that team's control room knows whether they have decided to use the NASA provided camera or not. So I'm not sure if the students can really see that it appears that their robot is driving on top of some wire harnesses is kind of what it looks like from this angle. It looks like all their wheels are still operating. Although they're not all quite pointing in the direction that would be productive. Meanwhile, time is running pretty low for these two teams, at least for their first run. Good news is that these teams will get another attempt at their official scored runs tomorrow. 2.5 minutes remaining in this run for University of Portland and University of New Hampshire. After this run, we will see Montana Tech University and the University of Arkansas. Arkansas is doing just a demo run, not for points. I don't remember if I mentioned this at the beginning of our broadcast, but we are so happy to be back and competing here live and being able to broadcast our competition, but being able to compete here live in person here at the Kennedy Space Center Visitor Complex, because it's been a few years. We've been forced due to circumstances beyond our control to take a few years off from this competition being live. And so we're really happy to be back, happy to have all these student teams back with us face to face. This year is our very first year using our brand new indoor Artemis Arena. And we couldn't be happier to have an indoor arena in a permanent facility that isn't subject to lightning storms shutting us down. About 30 seconds remain in this run for University of New Hampshire and University of Portland. And sadly, neither of these teams were able to get their robots out of the starting zone. But there is still time to make repairs, make fixes, make adjustments, and perform, try to make some progress and try and score some points in their second run, which will happen sometime tomorrow. We probably won't be advertising a specific schedule or a specific order of running until tomorrow morning, which you may have noticed today's initial schedule plan was posted this morning, fairly early this morning on Facebook. And so probably tomorrow morning will be the soonest that tomorrow's planned schedule will be posted on social media. Now, the link for tomorrow's live stream will be posted on our Lunabotics website probably tomorrow morning. And that link to our Lunabotics website is nasa.gov/Lunabotics. So first thing in the morning, if you go to nasa.gov/Lunabotics, you should be able to access our live stream link for tomorrow morning at that site. And it will also have links to all of our previous live streams right there on nasa.gov/Lunabotics. As the Portland and New Hampshire students removed their robots from the arena and waved goodbye, they'll be back tomorrow. We should soon see Montana Tech and University of Arkansas students come into the arena soon. So don't go anywhere. After Montana and Arkansas run, looks like we'll have North Dakota State, and then possibly running alone. And then after that, Lone Star College, Sci-Fair, possibly running alone. And I think that will be, if that schedule holds, I think those will be the last runs of our day today. And then we will have all day tomorrow to run all of these teams again with for their second run, their second official competition runs tomorrow. So don't go anywhere because you don't want to miss Montana Tech and University of Arkansas. Arkansas will be performing a demo run that will not be scored. You are watching NASA's Lunabotics Competition 2022, broadcasting live from the Kennedy Space Center Visitor Complex in sunny Central Florida. So as I said, Montana Tech will be running next, and University of Arkansas will also be running next as a demo run. One of our screens is telling us that after that, North Dakota State and South Dakota School of Mines will both be running. And then after that, Lone Star College Sci-Fair and University of Maine will be running.
NASA's Artemis mission will land the first woman and the first person of color on the moon. And today's students are the Artemis generation.
If you're a student, you can design and build technologies that support the Artemis mission with NASA's Artemis Student Challenges.
No matter your background or experience,
you're invited to choose a challenge that interests you, whether it's
rockets,
robots,
tools,
software,
vehicles,
or other technologies. There's an exciting challenge for you.
So find a mentor and build a team of students.
Review the rules and requirements.
And bring
your ideas
to life with NASA's Artemis Student Challenges.
Visit stem.nasa.gov/Artemis and see how you can join one of NASA's mission-related student challenges.
All right, you are looking at a live view from our Artemis Arena in the Lunabotics competition here at the Kennedy Space Center Visitor Complex. We have Montana Tech University on the right and University of Arkansas doing just a demo run, not for points, on the left. The students are in the middle of their setup time, which allows them to activate all of their equipment, activate their robots, and test them out, test some commanding to make sure everything is working before we start their runs. I'm glad to see that nearly 100 people have found the link to our new afternoon live stream. We apologize for our technical difficulties earlier, and sorry that we had to start a whole new URL on YouTube, but happy that so many people have been able to find it and continue watching our event today. Feel free to share this new URL on social media and let your friends and family know so that they can watch along with us. This Montana Tech robot on the right uses tracks, and what you're seeing centered at the top of the robot with the black arrow painted on it is a bucket. It's very similar to an excavator bucket, and it's on an arm, and it reaches out and comes back toward the robot, and we'll be able to bring in a large scoopful of the simulated lunar soil. And it looks like both teams have their robots ready to go, checked out, and they're exiting the arena because no students are allowed in the arena during a run. Only our full-time arena judging staff are able to be inside the arena during the competition. The teammates who are controlling these robots are not in the same room. They are not able to communicate with the students who are in the same room looking through the glass at their robots. The students who are controlling these robots are only able to look at the data being broadcast from the robot, and they're able to look at an overhead camera feed that we provide them, which simulates the lander's perspective or the lander's view of the mission. For any viewers who aren't aware, the mission for these robots is to leave the starting area, which is representing the lander that just dropped these robots off on the surface of the moon. These robots have to leave the lander. They have to cross an obstacle field. They have to get into the excavation area, which is on the far left of the screen. They have to dig down as far as they can because under the topsoil, we have hidden a layer of lunar ice, frozen water, and we're actually simulating the frozen water using some gravel, 1 inch, 2 inch diameter gravel. And once those robots pull that gravel up from beneath the surface, they need to cross all the way back over the obstacle course and deposit that gravel onto a sieve or a grate or a screen that is on the right side of the screen, which simulates the lander's hopper or bucket. We have had, over the 3 days that this competition has run so far, we have had several teams that were able to bring the gravel, the ice, back and deposit it onto the lander's hopper. We had Michigan Tech earlier in the week bring back 0.29 kilograms and deposit it. We had the University of Alabama. Now, these are not official scores or anything. There's a lot more that go into the official scores than just these numbers. And these are actually, even these numbers are actually unofficial. The judges may have more information than I have presented in front of me and on my tablet here. But so with that caveat, the University of Alabama team the other day deposited 5.2 kilograms of gravel. The University of North Carolina at Charlotte deposited 0.295 kilograms. The College of DuPage earlier deposited 0.05 kilograms. San Diego State University deposited 0.015. University of North Dakota deposited 0.04. And the University of Virginia deposited 0.035. Again, unofficial results, and there's a lot of variables involved in turning those numbers into an official final score for these teams. So we are waiting for Montana Tech on the right and University of Arkansas on the left to start their run. Montana Tech, this is their first of 2 attempts in the bin, official scoring attempts. The University of Arkansas on the left, this is just a demonstration run. This will not be scored. This will not be judged. And so we should see this run start hopefully in just the next few moments. All right, looks like we have some motion from the Arkansas robot on the left, which is just performing a demo run. To turn in place, the left wheels need to go backwards as the right wheels go forwards. And it's just there, things kind of maybe kicked into gear. You can see a little opening in the back of the robot, of that Arkansas robot. A little door in the back of that robot opened up. I'm not 100% sure because that seems like it's too low to be able to dump onto the lander's hopper. They just lowered something in the middle of the robot. I'm not sure if it's an auger or a spinning bucket drum, maybe. It's hard to tell from this angle. Now we can see that their rear hopper lifts up. So that makes a lot more sense to me. We're waiting for the Montana Tech robot to show some signs of life. Have yet to see. Oh, Arkansas just lost a wheel. That's not good. So it's possible that the wheel slipped off its axle, or it's possible that the axle snapped. So this is part of the. Let's go back to the overhead camera view. I'm not sure if it just ran over the rock. No, it's still pretty far from the rock. It must have pushed itself up in midair based on plunging its digging mechanism into the ground. From this camera angle, we can actually see in the center of the robot is some sort of drum in the middle of the robot. And from this angle, you can actually see the remaining rear wheel is kind of cantered at an angle that maybe is not ideal for the wheel to be at. This may be what happened to the other rear wheel right before it snapped off. We can see from this angle that the front right wheel, which is on the other side of that rock, is spinning. Okay, they're pushing their digging mechanism down and lifting the front of their robot. Again, this is Arkansas, University of Arkansas, just performing a demo run, not for points. They're really pushing their digging drum into the ground. You see one of their front wheels is spinning, but the other one is not. I don't know if they intend for both of them to be spinning right now or not. These Arkansas students may have given up the idea of driving the robot around the bin as soon as they lost their rear right wheel, and they may be content to just move all of their actuators and move all of their motors, just to give them some demonstration, some test time. Angle, you can see their rear. I guess you'd call it a dump bed. Their rear bed that has a door in the back of it. So their center-mounted digging drum probably lifts up. We haven't seen it lift up yet, but it probably lifts up and then kind of fits or matches in with the cutout in their rear dump bed. We're 8 minutes into this 15-minute run, and we have not seen Montana Tech University's robot move from its starting position. We're now 10 minutes in, 5 minutes remaining in this demo run for Arkansas. It looks like their digging mechanism has pushed their robot all the way on top of the rock obstacle that has been placed in that particular spot. Now the whole left side of the robot is in midair. And the right side of the robot appears to be the only wheel that is spinning. And the right side of the robot is missing the rear wheel. I would like to see, if possible, I would like to see their digging mechanism come up so we can see how it's intended to dump into their onboard hopper. Looks like they're lifting it up now. Their hopper probably needs to be in a fully lowered position, I suspect, in order to dump into it. Oh, is it? Oh, I thought I saw their digger spinning, but I think it was just the lights that tricked my eyes into thinking it was spinning. So the fact that the Arkansas robot lost one of its wheels it's really not super surprising that can happen in a competition like this, because these teams are needing to make their robot as lightweight as possible and use as little power as possible while still completing the mission. And so sometimes they cut their margins a little more than is necessary in order to complete the mission. For example, this robot may have worked perfectly fine on beach sand, but the forces that ended up being on this robot in this crushed volcanic rock, which is light and fluffy on top, but is very tough underneath and very resistive to digging forces, resistive to driving forces, especially if those forces are trying to force a wheel crossways across its direction of normal travel. Those forces can be high enough to break parts if those parts were not designed to be strong enough. But there's no simple solution. The students have to walk this fine line, because if they just over design every possible piece and part and fastener and bolt on the robot, then it's going to come in way heavy. It may be so heavy that it's completely disqualified. There are weight limits in the rules. There are volume limits in the rules, and so it's all an engineering trade-off that these schools have to figure out. They have to solve the puzzle and tweak all the different variables that they can tweak in order to try to find the sweet spot, if you will, for strong enough to perform the mission, but not going beyond that and adding wasteful mass to their robot. So with that, this run winds down. Time runs out for University of Arkansas's demonstration run and Montana Tech University's first of two official competition runs. Montana Tech is going to be able to come back tomorrow for their second of two competition runs, and hopefully whatever their issue was will be fixed by then, and hopefully we'll see them perform well when we see them tomorrow. So right now my screen is telling me that only North Dakota State University is coming up next, but earlier we had a different screen that told us both North Dakota State and South Dakota School of Mines were coming up next. So I guess we'll find out when either one robot or 2 robots comes into the arena next. So don't go anywhere. NASA's Lunabotics competition continues in just a few minutes. Breaking news. My screen just updated, and it's telling me that the very next run is North Dakota State University and the University of Maine. And then after that, we have Lone Star College Sci-Fair, and I suspect that will be our last run. But if I see anything different show up on my screen, I will broadcast that immediately to the stream. Thank you for watching, and don't go anywhere. Coming up next is North Dakota State University and the University of Maine.
One of the focuses of the project is to help advance commercial technology. My name is Laura Evans, and I lead a team of researchers in 3D printing the next generation of rocket engines. We can create designs, rapidly look at them, prototype them. We can turn around parts in months. We're looking at 2 main processes. They both use metal powders to create the part. The challenge is making sure they're just as strong and they're going to work as well as conventional manufacture. We do these hot fire tests, and then we see if it falls apart. We're pushing the envelope so much that things don't work all the time. And it's not like it's a disaster because you learn from it. This is a scanning electron microscope. This is just showing you what the electrons look like as they come off the sample. And I was used to running for a team. So I ran in college, I ran in high school, and I met people at NASA who ran. That's also how I got into marathons. I never would have dreamed that I would be working on rocket components. So it's really nice to be able to come to work every day with these researchers who actually developed these materials years ago, and they're still being used in rocket engines and turbine engines, and they're still really valuable in the world.
To go after something as challenging as spaceflight. That's what NASA's all about, is pushing the boundaries, pushing the limits. We really do challenge ourselves to go out and achieve things that nobody else does. My name is Michael Aldridge, and I make history every day. I have the honor and privilege of getting to lead a multidiscipline team that's responsible for the design for thermal protection systems hardware for the SLS core stage launch vehicle. It's the center launch portion of the vehicle so that we can do exploration and we can go deeper and farther and faster. So we're at the Michoud Assembly Facility, which is America's rocket factory. This is where we take raw components and we shape nature into a spaceship. And in this case, the biggest launch vehicle ever devised by humans. I mean, this is pretty intense stuff. For me, personally, the way I learn, I just got to roll up my sleeves and get my elbows dirty. It's kind of a pinch me kind of thing to really see it go from paper to real tangible hardware that we're really going to go fly. Is very exciting for me to really get to be a part of that, to be where I am. I really consider myself fortunate and blessed.
Even though it is late in the day here at NASA's Lunabotics mining competition, you can see from this live feed from our RoboPit area that students are still working on the robots. There's still a lot of energy, a lot of excitement. These teams are getting ready for their second, a lot of these teams are getting ready for their second of 2 competition runs, which will occur tomorrow. And I'm not sure yet that they know what order they will be competing in tomorrow. So these teams probably have to get the robots in operating order before they leave tonight, just in case they end up being early in the schedule tomorrow. I could be wrong. I'm not completely plugged into the process here. Meanwhile, in the arena, we have our next 2 teams, as you saw a few seconds ago, putting their robots into the arenas. We have on the A side, which is the right side, we have North Dakota State University. And on the B side, which is on the left, we have the University of Maine. The students are powering on their robots and verifying that everything's working. University of Maine on the left and North Dakota State University on the right. You can see the students communicating on the radios with their teammates in their control rooms as they check out their robots over the network. They'll be looking for data. They'll be looking for possible video feeds from their robot. If their robot has onboard cameras and is sending video feeds, they'll be looking for maybe sending some test commands, like maybe an arm movement or a quick test of a wheel, for example, things like that. Or a quick motion of the robot, like we just saw from the North Dakota State robot. And then hopefully, once all the students are happy that everything's working fine, they will then exit the arena, and the judges will put the final touches on the arena, and they will communicate their status to the head judge. So now that we're getting a clear view of the North Dakota State University robot on the right, it looks like this may be just kind of a demonstration because it's not obvious to me that this robot has its digging mechanism in place right now. Okay, we have a last second schedule update. Thanks to our pit boss who came into our broadcast room to give us the skinny. The North Dakota State University robot on the right, as I was just saying, their digging mechanism is back in the pits. They're not actually going to be doing any digging during their first of 2 official competition runs. This is not a demo. This will still be a scored run for this team, and hopefully they'll get their digging mechanism all working tomorrow and be able to have a chance, have an opportunity to dig down and get that gravel and bring it back and deposit it on the hopper during their second run tomorrow. And as we were saying earlier, that there was going to be one more run after this. That run actually is not going to happen, and we're off. So the run that you are seeing right now between North Dakota State University and between the University of Maine is going to be our final run of the day. And so, just looking ahead, tomorrow we will start broadcasting. Do we know? Tomorrow we will broadcast all day long. I'll tell you in a minute what time our start time is. And tomorrow will basically be all of the teams that are here Thursday and Friday will get a chance to perform their second official competition runs tomorrow. So we are scheduled to broadcast starting at 9 a.m. tomorrow. And the link for tomorrow morning's broadcast will be posted on our Lunabotics page tomorrow morning. So make sure you go in the morning, make sure you go to nasa.gov/Lunabotics in order to find that link to Friday morning's live stream. This view gives us a good view. It looks like there are some pieces falling off of the North Dakota State University. They have some really interesting wheels that they're trying out this year on the North Dakota State University robot. Their wheels are kind of, I want to say conical, but it's like two cones put together. And so the wheels actually peak in the middle and then they tail off towards both directions. Is there have, oh, there you can see in this camera view, you can see that the wheels kind of tail off from the center, but then where the wheels tail off from the center, the students have installed these flippers. That's probably not the best word, but it's the only one that I can think of right now. These little metal flippers onto their what looked to me like plastic wheels, although I may be wrong there. And it looks like some of those flippers may actually be falling off as they drive their robot, because we saw the judges kind of pulling those pieces out of the arena just a second ago. "11 minutes remain in this 15-minute run. Last run of the day for today. However, all of these teams get another run tomorrow in our competition. So we're not actually broadcasting or publishing live results during the competition this week. We're actually planning on, and the students should be fully aware by now, that we're scheduled to broadcast an award ceremony next week, and this should already be on the students' calendars. They should already know how to access that. So we will hold all of our results until that broadcast next week. So we're not actually going to have a live in-person award ceremony this year. Our opening ceremony was broadcast remotely to the students last week, and our award ceremony will be broadcast live to the students next week. In this overhead view, you can see the tracks left behind in this crushed volcanic rock from this North Dakota State University chassis. It was able to make a turn of 20, 30 degrees probably, but I suspect that they are trying to turn more than that. That what they really needed to probably do is make a 90-degree turn in order to head in the direction of the digging area. And what we just saw there was not all four wheels appeared to be spinning simultaneously. So unless they were trying to turn, you would want all four wheels to be spinning. So with a skid steer or a tank steer robot, right there, we just see only one of the four wheels spinning just there. With a skid steer or a tank steer robot, you basically want the two left wheels to be in sync, and you want the two right wheels to be in sync. And if you want the robot to drive straight, you drive all four wheels at the same speed. But if you want the robot to turn while driving straight, for example, if you want the robot to turn to the right while also driving straight, then you drive all four wheels forward, but to turn right, you drive the two right wheels a little less than you drive the two left wheels. I know I'm not explaining this very clearly. You want to drive your right wheels at a lower velocity or slower than your left wheels. And if you do that, your robot will arc to the right. If you want to just turn in place without driving forward or backward, and you just want to spin in place to the right, then you actually drive your right wheels backwards and your left wheels forwards. If your right is going back and your left is going forward, then you're basically spinning in place clockwise. And so when we see a robot where only one wheel out of the four is spinning, that's not productive. And that's probably not on purpose. That means something has gone wrong somewhere, either mechanically or electrically or possibly even in software. There's a lot of links in this chain to make everything work smoothly. And we're about 9 minutes in, about 6 minutes remaining in this 15-minute run for the University of Maine and North Dakota State University, our final run of the day. Sadly, we have not seen any motion from the University of Maine robot in this 15-minute run so far. So hopefully the students are able to figure out what is going wrong there and are able to easily correct it and have a good, successful second run tomorrow. In order to find out the order that teams will be running in tomorrow, make sure you check back in the morning on our social media channels like our Facebook page, which can be found on Facebook by searching NASA Lunabotics. Our Facebook page will come right up. Our schedule could be posted there. If not, our schedule will be verbalized over this live stream tomorrow morning as soon as we see a schedule on our screens. And again, we are planning on starting this live stream at 9 a.m. tomorrow. But as I said before, and as we found out this morning, our plans sometimes change. And so just monitor our website, nasa.gov/lunabotics, monitor our social media on Facebook, and thank you for being flexible and understanding, as this event is definitely a moving target as far as scheduling goes. Thank you for your flexibility and your understanding. It looks like we're down to about a minute remaining in this first run for University of Maine and North Dakota State University. Looking forward to both of these teams' second runs tomorrow. I did get a look at North Dakota State University's digging mechanism over in their pit earlier, and it does look impressive. So I can't wait to see their second run tomorrow, which will hopefully include their digging mechanism. Hopefully they're able to get whatever finishing touches need to be put on that system in order to run it tomorrow. And so as time runs out on this, our final run of the day, we thank you so much for watching our event this year, and come back tomorrow morning and we will continue our live stream. Tomorrow will be our final day of competitions, our final day of runs for Lunabotics 2022. So don't miss it. Come back tomorrow morning, and we hope to see you all then. And make sure you share, once you see our live stream link, make sure you share that on social media and tell all your friends and family so that they can watch along with you. Thank you, and we will see you tomorrow.